you an easy method to evaluate trig functions mentally. Things like sine of pi over 6, cosine of 5 pi over 4, or tangent of negative 2 pi over 3. If you studied pre-calc with me, you already learned how to evaluate these using our common right triangles from geometry, the 30-60-90 triangle and the 45-45-90 triangle. You also learned how to evaluate these using the unit circle. Well, today I'm going to teach you an easy method I call the 1, 2, 3 method. It's essentially a method that will allow you to use the unit circle when you don't have a unit circle without needing to memorize the entire unit circle.
Of course, trigonometry is the study of the relationship between sides and angles of triangles, so we first learn to evaluate trig functions using our two common right triangles. I know pi over 6 is 30 degrees, 180 divided by 6 is 30. So sine of 30 degrees is opposite over hypotenuse. Sine of 30 degrees is 1/2. To evaluate cosine of 5 pi over 4, let's first determine which quadrant the angle 5 pi over 4 is in. I'll count my way there. 1 pi over 4, 2 pi over 4, 3 pi over 4, 4 pi over 4. Here's 5 pi over 4. We're in the third quadrant, and all-star trig class tells me that tangent of this angle will be positive, but sine and cosine would both be negative. I know cosine of 5 pi over 4 is going to be negative. My reference angle is the angle this makes with the x-axis. I see my reference angle is 45 degrees. So I'll find 45 degrees on my common right triangle, and I know cosine is adjacent over hypotenuse. Adjacent over hypotenuse would be 1 over square root of 2. And we could, of course, rationalize this denominator. Let's multiply by radical 2 over radical 2. 1 times radical 2 is radical 2, and radical 2 times radical 2 is 2. Cosine of 5 pi over 4, or cosine of 225 degrees, is negative radical 2 over 2. And let's also see which quadrant this angle negative 2 pi over 3 is in. I'll start at 0 and count my way there. Negative 1 pi over 3, negative 2 pi over 3. Once again, I'm in the third quadrant, and all-star trig class tells me that tangent of this angle would be positive. My reference angle is the angle this makes with the x-axis. I have a larger reference angle this time. My reference angle is 60 degrees. I'll find 60 degrees on my common right triangle, and I know tangent is opposite over adjacent. Tangent of negative 2 pi over 3 is positive radical 3. This process became even easier when we were permitted to use our unit circle. To evaluate sine of pi over 6, we just find pi over 6 on the unit circle, and your cosine and sine value are right there. Sine of pi over 6 is 1/2. We find 5 pi over 4 on the unit circle. Here's 5 pi over 4, and cosine and sine are right there waiting for you. Cosine of 5 pi over 4 is negative radical 2 over 2. The unit circle contains all the sine and cosine values, but it's a little bit trickier to evaluate tangent. That is, of course, unless you're using a unit circle that has all the tangent answers written down. To evaluate tangent of negative 2 pi over 3, I'll just count my way to negative 2 pi over 3. Negative 1 pi over 3, negative 2 pi over 3. Tangent is positive radical 3. Well, let's learn the 1, 2, 3 method, which will essentially allow you to use the unit circle without requiring you to memorize the entire thing. Step 1 is to draw your x and y axis and label the points 1, 0, 0, 1, negative 1, 0, and 0, negative 1. In step 1, you put all the 1s. Step 2 is to jot down the 3 fractions that all have 2 in the denominator. And our numerators are easy to remember. This is the square root of 1, the square root of 2, and the square root of 3. Of course, the square root of 1 is just 1. In step 2, you put the fractions with the 2's. And step 3, we're going to jot down radical 3 and radical 3 over 3. In step 3, we jot down our values involving the number 3. Now we have everything we need. We don't need that whole entire unit circle. Up here, we have our sine and cosine answers, and right here, we have our tangent answers. Let's first learn how to evaluate sine of an angle. Sine is always the y value. So to evaluate sine of 2 pi over 3, I'll spin to 2 pi over 3, 1 pi over 3, 2 pi over 3, and I'm only concerned with the y value. To get to 2 pi over 3, you go over a little bit, but you go up a large amount. The large amount is radical 3 over 2. Let's evaluate sine of 7 pi over 6. 1 pi over 6, 2 pi over 6, 3, 4, 5, 6. Here's 7 pi over 6. To get to 7 pi over 6, you would go over a lot and down just a little bit. The small value is 1/2, and we're going down 1/2, so this is negative 1/2. Let's spin to 7 pi over 4. 1, 2, 3, 4, 5, 6. Here's 7 pi over 4. To get to 7 pi over 4, you would go over and down this medium amount. Since we're going down, it's negative, and the medium amount is radical 2 over 2. Let's go to 3 pi over 2. So pi over 2, 2 pi over 2, 3 pi over 2. Sine is negative 1. And finally, let's go to pi. Well, over here's pi. Sine is 0. When we evaluate cosine of an angle, we're concerned with the x value, or how far left or right we go. Let's spin to 2 pi over 3. 1 pi over 3, here's 2 pi over 3. To get to 2 pi over 3, you would go to the left a short distance and up a large distance. But we're only concerned with the x value, or how far left or right we go. We go to the left, so it's negative. And we only need to go to the left a short distance, so it's negative 1/2. Let's spin to 7 pi over 6. 1 pi over 6, 2 pi over 6, 3, 4, 5, 6, 7 pi over 6. To get to 7 pi over 6, you would go to the left a large distance and down a short distance. We're going to the left, so it's negative, and we have to go a long way to the left, so it's negative radical 3 over 2. If you haven't caught on yet, this is our short distance, our medium distance, and our long distance. Let's see where 7 pi over 4 is. 1 pi over 4, 2 pi over 4, 3, 4, 5, 6. Here's 7 pi over 4. To get to 7 pi over 4, you would go to the right a medium amount and down a medium amount. We're going to the right, so it's positive, and we're going to the right a medium amount, it's positive radical 2 over 2. Cosine of 3 pi over 2 should be easy. Here's 3 pi over 2, cosine is 0. Cosine of pi is easy also. Here's where pi is, cosine is negative 1. Perhaps you recall from trigonometry that tangent is equivalent to sine over cosine, which means tangent is y over x. Recall that change in y over change in x is slope. Let me show you how you can use the slope of a line to determine tangent of any angle. Let's go to 2 pi over 3, 1 pi over 3, 2 pi over 3. Well, I can evaluate tangent of 2 pi over 3 by just considering the slope of this line. Notice it's going downhill. It has a negative slope. And it's quite steep. It's much steeper than, say, this line would be. So we want to choose our larger tangent answer. We want to say negative radical 3. Let's go see where 7 pi over 6 is. 1 pi over 6, 2 pi over 6, 3, 4, 5, 6. Here's 7 pi over 6. I can evaluate tangent of 7 pi over 6 by considering the slope of this line. Notice this line is going uphill. It has a positive slope. And this line is not very steep. This would be a very steep line. But this line, not so steep. Let's use our smaller tangent value. Tangent of 7 pi over 6 is positive radical 3 over 3. Let's find 7 pi over 4, 1 pi over 4, 2 pi over 4, 3, 4, 5, 6, 7 pi over 4. Let's consider the slope of this line. First, notice that it's going downhill. It has negative slope, and it's going downhill at a perfect 45-degree angle. We could say it's going like down 1 over 1, down 1 over 1. The slope is negative 1. Let's evaluate tangent of 3 pi over 2. Here's 3 pi over 2. This line is ridiculously steep. It's perfectly vertical. We could say it has a slope of infinity, or in other words, undefined. And we'll evaluate tangent of pi. Here's pi. And the slope of this line is, of course, 0. Tangent of pi is 0. So let's quickly summarize how to use the 1, 2, 3 method. First, draw your x and y axis. Step 1, label all the points involving the number 1. Step 2, jot down the 3 fractions with 2 in the denominator. It's the 1, 2, 3 method. The numerators are square root of 1, square root of 2, and square root of 3. Step 3, jot down your tangent answers involving the number 3. Radical 3 and radical 3 over 3. Now you have everything you need. Sine of pi over 6. Let's find where pi over 6 would be. Pi over 6 is right about here. And when evaluating sine, we're only concerned with the y value. To get to pi over 6, you would go over a long distance, but up or positive a short distance, positive 1/2. Let's see where 5 pi over 4 is. 1 pi over 4, 2 pi over 4, 3 pi over 4, 4 pi over 4. Here's 5 pi over 4. When evaluating cosine, we're only concerned with the x value, or how far left or right we go. We're going to the left, so it would be negative. And we're going to the left that medium amount. It's negative radical 2 over 2. Let's finally see where negative 2 pi over 3 is. Negative 1 pi over 3, negative 2 pi over 3 is right here. And to evaluate tangent of an angle, we need to consider the slope of this line. First, notice that it's going uphill. It has a positive slope. And the slope is quite steep. We're going to choose the large tangent answer. It would be positive radical 3. All right, I hope you enjoyed learning the 1, 2, 3 method. It's time to go do those try these.